Are you an undergraduate or postgraduate student? Do you work as an M&E consultant or you are a research practitioner? Do you find research methods such an abstract unit in the course of your study or in the course of your work? And this is because you cannot relate the research theory you learn or you learned in class with practice. Then this channel is for you. I, Dr. Lydia Wabogo, welcomes you to this channel, which is a class on research methods. In this class, we discuss everything social science research, from understanding the research discipline, research philosophy, elements of scientific research, and the methodologies of conducting research. Welcome to this channel as we explore this discipline called research. Welcome to today's lesson, where we shall be discussing methods of determining sample size in quantitative research. In our previous lesson, we have introduced the topic on sampling. We have explained 12 terminologies that are used in sampling, and some of the terminologies that we have explained are sampling, and we have said that sampling is the process of selecting a subset of the population that will be used in the study. We have also explained what a sample is as the subset of the population. We have explained what is a population as that characteristic that is of interest to the researcher. We have also explained what is an element, a subject, a parameter, a statistic, etc., etc. We have also discussed 6 purposes of sampling, and we completed the lesson by discussing the limitations of sampling. In this lesson, we are going to discuss the factors that you put into consideration when determining the sample size, as well as the strategies or the methods that are available to the researcher when they are determining the sample size. So before we get into the lesson, let us familiarize ourselves with the learning outcomes of this lesson. At the end of this lesson, you should be able to 1. State the factors to consider when determining the sample size, and 2. Explain the strategies or the methods that you employ to determine the sample size. So let us move together. In lesson 28, we have said that a sample is a subset of the population that is chosen for participation in a study. Determining the adequate sample size is the most important decision that a researcher needs to make. Sample size is the number of subjects that is used in a study, and it is normally abbreviated as small n. So note that the number of people whom a researcher will use in the study is what we call a sample size. Contrary to popular opinion, samples are not selected haphazardly. Rather, they are chosen systematically so that you can confidently make certain inferences about the characteristics of the population from which it was drawn. Note that we study a sample and then we make generalization to the population. That means we must be confident that the sample we have selected represents the characteristics of the population. That is why we are saying that for us to make inferences about the characteristics of the population, then we must draw a sample systematically. The ideal sample is large enough to serve an adequate representation of the population about which the researcher wishes to generalize, and small enough to be selected economically. If the sample is too small, it will not yield varied results, and it will not adequately represent the population being studied. On the other hand, while larger sample sizes yield smaller margins of error and are more representative, a sample size that is too large may significantly increase the cost and time to conduct the research. Now, one may be wondering, then which is the ideal sample? What is the ideal sample size? Now, this lesson will take you through the factors that you consider so that you can choose an ideal sample, as well as the strategies that you employ to select that sample. Let us look at the factors that we need to consider when determining the sample size. The first factor that you need to put into consideration is the type of research that you are conducting. Quantitative research uses statistical methods of determining the sample size, whereas qualitative research utilizes judgmental methods of determining the sample size. In addition to that, quantitative research requires a sample that is representative of the population, whereas qualitative research requires a sample that is information rich. So the type of research or the approach of research that you are using is one factor that you need to put into consideration when determining the sample size. The other factor is confidence level or confidence interval. In statistics, confidence interval or level refers to the probability that a population parameter will fall between a set of values for a certain proportion of times. For instance, a 95% confidence level means that should you repeat a study over and over again, 95% of the time, your results will match the results you get from a population. So what are we saying? We are saying that the confidence level gives us the probability that the sample contains the parameter being estimated. I hope you remember from our lesson 28, we defined the term parameter and we defined the term statistic. So what we are saying at the confidence level is that the confidence level is the probability that the sample contains the parameter that is being estimated. In social science research, we mainly use 90% or 95% confidence level. The level of confidence has a positive relationship with the sample size. That is, if you hold all other factors constant, the higher the confidence level predetermined, the larger the sample size needed. That means for you to have a high confidence level, then the sample size must be large enough. For example, the sample sizes that are needed when the confidence level is 90%, 95%, and 99% at plus or minus 3% precision level is 699, 964, and 1556 respectively. So you can see that the higher the confidence level, the higher the sample size is needed. Then we discuss the factor number 3, which is the level of precision. Precision is the same as the sampling error. Sampling error is defined as the relationship between the statistic, that is the numerical value of a sample, to the parameter, which is the numerical value of a population. Precision gives the researcher an idea regarding the accuracy of the statistical estimate. Do not forget that we use a sample to describe a population, and therefore precision gives the researcher the idea regarding how accurate the statistical estimate he or she making regarding the population is. Precision in most cases is expressed in percentages such as plus or minus 3%, plus or minus 5%, plus or minus 7%, or plus or minus 10%. Therefore, if a researcher finds that 85% of the students have a positive attitude towards a subject with a precision level of plus or minus 5%, then the researcher can confidently conclude that between 80 and 90% of all the students in that population have a positive attitude towards the subject. Somebody may be wondering, where are we getting the 80 or 90%? We are making an assumption that if a researcher was conducting a study on attitude of students towards a particular subject, and he finds that 85% of the students have a positive attitude towards that subject with a precision level of plus or minus 5%, then the conclusion the researcher is making is based on 85 minus 5 and 85 plus 5. The larger the sample, the greater the precision. Factor number 4 is population size. The sample selected should be representative of the population from which it is drawn. This factor is especially true for quantitative research, where generalization of research findings is key. Therefore, the sample that you draw in a quantitative study should be representative of the population. The final factor is the non-response rate. In any research study, there is the number the researcher selects from the sampling frame and the actual number of the subjects who responds to the instrument in that study. So what is the actual sample size? Sample size refers to the number of varied responses, not the number of subjects, meaning that the sample size that the researcher had is not the number of subjects who were selected to participate in the research. Rather, it is the number of subjects who responded correctly to the survey. So again, the word subject that we are using is one of the terminologies that we defined in lesson 28. The difference between the number that was selected and the number that actually responds to the survey is what is referred to as the non-response rate. As non-response rate increases, the possibility for having a biased sample also increases. Therefore, as the researcher selects a sample size, they should ensure that they reduce the non-response rate as much as possible. So with those factors, we'll now look at the strategies that we use or the methods that we use to determine the sample size. We have about 5 methods, and the first one is using a census for small populations. For small populations, it is possible to use every element in the population in your study. When you use a census, it eliminates the sampling error and provides data on all the individuals or elements in the population. But the question we need to ask ourselves is, how small is a small population? Strategy number 2 is using a sample size of a similar study. So this is where you use the same sample size as was used by another researcher who conducted a study that is similar to yours. However, with this method, you need to be careful because you may run the risk of repeating errors that were made in determining the sample size for that study. Method number 3 is using Internet Sample Size Calculator. This method, which is more scientific than the first two, utilizes the internet sites that helps one to determine the sample size. One such site is the address that is given. Our next slide will show us a screenshot from this site. So once you open the internet, you open the sample size calculator, you'll be able to enter the confidence level, which is 95%, the margin of error or the precision, which is 5%, the population proportion, which we input 50%, and then the population size, which in our case we can use an example of 500. Then once you have filled the table, then you click on calculate, and you can see the second output shows us that when you have a population of 500, then the sample size will be 218. Another strategy that you can use is using published tables. These tables are designed exactly in the same way that the internet calculators are. This is another method that is highly scientific, and they provide the sample sizes for a given criteria. Two commonly used tables are Craigie and Morgan table and Grain table of 1970 and 1992 respectively. So when you open Craigie and Morgan table, it shows you capital N, which is the population, and it also shows you the sample size that you need to draw from that population. For instance, for a population of 10, Craigie and Morgan table advises the researcher to use a census because you can see the sample size is 10. But when you increase the population size to 15, then the sample size becomes 14. When the population is 1900, then the sample size should be 320, etc., etc. From Craigie and Morgan table, we can see that as the population increases, the sample size increases at a diminishing rate and remains relatively constant at slightly more than 380 cases. Grain's table gives us the sample size at different precision levels. So when you increase the precision level, the sample size decreases, like we had mentioned earlier as we were discussing the factors that you need to put into consideration when determining the sample size. The final method of determining the sample size is using mathematical formulae. The commonly used mathematical formulae in social science research are Yamane 1967 and Cohen. We shall demonstrate the use of Yamane formula. So when we are using Yamane formula, small n is the sample size, capital N is the size of the population, whereas E is the margin of error or your level of precision. In most cases, we use 5% significance level or margin error. So again, using the same example that we had where N is 500, so we shall input where we have capital N and we put 500. We should be divided by 1 plus 500 multiplied by the margin of error, in our case is 0.05 squared. Now when we calculate, we get that n is equals to 222. You can see that the variation is not so much when you are using the table, when you are using the internet calculator, and when you are using the mathematical formulae, meaning that the last three methods are more scientific than the first two. Though the first one, where you are using the sensors, it means you have no sampling error. And with that, we have come to the end of this lesson. In this lesson, we have discussed the factors to put into consideration when determining the sample size, and we have also discussed the strategies or the methods that you employ to determine the sample size. In our next lesson, we are going to discuss random sampling technique. Thank you for your time in this lesson. Feel free to ask any question regarding this lesson on the comment section. Do not forget to subscribe to this channel and also to like and share this video with your friends. See you in our next lesson as we discuss random sampling techniques.